Okay, everyone, we're going to get started. It's a little bit after the hour. I thought I might wait a little longer because, as all of you saw, we've implemented, I already joked about this, we've implemented the Damp Lab exercise program. That's where you get the opportunity to take 9 flights of steps up here and come in. So don't let no one say that we're not into an active lifestyle. So, again, what I want to do is welcome all of you guys to the second international workshop on biomanufacturing automation. I'll talk about why this is the second one and what the first one was, etc. I'm Doug Densmore. I'm a professor of electrical and computer engineering here at Boston University. I'm affiliated with many departments, but the reason I'm speaking with you today is I'm the director of the design automation lab here called the DAMP Lab, which stands for Design, Automation, Manufacturing, and Processes. And as you'll see, we joked about that lab because when it was created, the joke was it's not really a dry lab, it's not really a wet lab, it's this combination of both, where we have computational expertise coming together with experimental expertise to move forward the engineering of biological systems. All right, so before I begin, I want to thank folks right off the bat. We have a number of folks that have responsible for this from a sponsorship standpoint. I hope that many of you will sponsor in the future, but again, the Material Science and Engineering Department, Eppendorf E-Labs, Hamilton MITRE, Aligned to Innovate, and Opentrons were all key folks in having this workshop happen. We'll talk to all of you when you'd like to about sponsorship opportunities, learn more about being a DAMP Lab member, and you're going to see these sponsors put out throughout the event. So I want to motivate, why are we having this workshop in the first place? Well, the idea is that if you look at biology, there's this idea that we have to have reproducible results. We have the idea of an automated lab, and the idea that if you introduce automation into the laboratory environment, it doesn't look like a robot butler. It's likely taking equipment that manufacturers and vendors, like many of you in this room, have adapted to be high throughput, to be semi-automated, to stand alone, and put those all together in kind of a assembly line, if you will, to put together biological systems. So the time is now, I think, to start thinking about how those workflows look, what equipment and software needs to be in those labs, and the general services you can provide. The other thing you're going to learn about is there's a number of initiatives around biomanufacturing, or making health more resilient, or introducing companies into synthetic biology, or as you'll hear about how we can put together laboratories in a network. You'll hear about MITRE talk about the BioNet initiative. So there are initiatives going forward now that want to look at distributed manufacturing. And I do consider this endeavor a manufacturing effort. You're manufacturing a biological system. And I think there are many analogies to manufacturing mechanical systems, electrical systems, et cetera. And then, of course, there are many challenges facing us: climate change, potentially human health threats, smart energy, smart plants, smart crops, things to help the world sustain itself. And so, again, these are all the kinds of factors that are coming together. So the vision, and this is a vision, and anyone who's been around me has seen this ad nauseum. The vision is something like this. So these, if you look at this from very far away, you see just a bunch of tacos. But apparently, and you guys can tell me if you've heard of this place, it's called Taco Bell. Apparently, it's relatively popular, and they've made a whole business around taking a relatively small number of ingredients and rearranging them in interesting ways. So taking, cheese, lettuce, different types of meats, shells, they offer a diverse menu, relatively speaking, to people at different price points and different interests in what they want to eat. If you go to a kiosk for that, you can then parameterize it. You can say, well, I actually want this added, I want double this removed. So again, even within that, you can customize them. And they've been successful, and they've taken that model and they've franchised it. So if I get a Taco Bell in Boston, I Taco Bell in California, Taco Bell in Canada, Taco Bell in Europe, presumably you're getting a pretty consistent experience. They've changed things to be kind of region specific to some extent, but you're getting a consistent experience. And then when you go to work at Taco Bell, you're trained in a way to go through a relatively standardized process. You don't get to say, well, today I'm gonna put the taco together this way, and tomorrow I'm gonna do it this way. You put it together in a very regular way, which allows them to give you that consistent experience, but it also allows you to have transient workers, relatively speaking. Very few people work at a Taco Bell and say, this is what I'm gonna be doing for the next 30 years. They come in for a summer, a year, then they come out and they leave with some skills, but then they're able to have new workers come in very regularly. I think this analogy is an interesting one to think about manufacturing. How do we take a relatively stable set of services and put them together in interesting ways and train a workforce that can benefit from being in that position, but also can be moved in and out seasonally as conditions change, etc. And this is something else from Taco Bell. So if you look at Taco Bell and you look at the way management thinks of it, they think of it as having aspects of having customers. They have where customers come in, where the kitchen starts, and how they move through this. And they can think about where there are bottlenecks in their process. They can go down to where you need more or less employees, who needs to be trained, where consumables are used. Again, you could think of this in a lab setting. You could think about these are the bottlenecks, these are the pinch points, et cetera. So again, I know we're not building Taco Bell, but I also don't think we're building a 3-star Michelin restaurant either, where whenever anyone wants something special, you make it for them. Whenever somebody says, I want a very gourmet specialized meal just for me, I think that has a place in biomanufacturing. But a lot of what you're going to hear over the next couple of days is how we standardize and systematize a process that looks much more like this. So again, to my point, what we might think of is that workflow. Instead of putting tacos together, you're systematizing a workflow where you have an intake. There's something done experimentally on a computer that then is processed through a series of standardized stations, maybe by humans. Then it comes to a highly automated section and then returns back to where the person started, presumably a computer or wherever the intake is. So it goes through this process. It's relatively standardized, and you can slot things in and out as that process scales. And then what is your menu? Again, you may not be able to read all of this, but again, now in the column there is all the services, cell transformation, things like colony assays, library prep, different assembly techniques. So instead of the tacos and burritos, now you have all of the different things you might want to build. And your ingredients now maybe are on the top, or the categories. So not only can you categorize the services you offer, but you could also talk about what reagents they use, which consumables, which hardware, and that again provides your menu. And I think the sweet spot is, given a relatively small number of resources and elements, how robust and rich can your menu get? And I think that's where the real innovation is going to come from. So instead of sitting at a kiosk and picking out my taco ingredients, I might sit down at a computer software program and say, these are the things I want to do. And they might be icons like this. I want to utilize a robot to make a library. I want to barcode something. I want to do the sample prep. I'd move through, and there's some level of abstraction that the user would interface with. They wouldn't be saying pipette 3 nanoliters. They would be saying something much more high level. That would then be translated to a series of standardized protocols that the lab has. So now going from this high level description is a compiling process where those individual elements now become more specified. They have inputs and outputs. You can talk about inputs being correct. So again, the same way when you put a program together in computer science, it can tell you if there's an error before you actually compile it or you run it. So we could do those things up front, which would save time and money. And then at the end of the day, it actually becomes code that executes on the equipment, removing ambiguity, et cetera. What I said early on in the talk with those first couple news articles or journal articles was reproducibility. When people talk about this, they hear robots and they come to me and say, well, we can do lots of things. I think throughput is really important, don't get me wrong. But if I made a lot of bad tacos quickly, it doesn't matter. You want to do things that are reproducible and of a high quality. And then we talk about scale. So again, I focus, a lot of this is reproducibility, meaning the more we capture this, the more I can say I did something. And I don't say I did something by giving you my notebook and saying, look what I did. You're actually giving them an electronic manifest of protocols, bills of materials, robotic code, actual entries in databases for samples. So there's an unambiguous way to reproduce what you've created. If you did that, you could have a network of different locations all performing these services. So I showed the Taco Bell map. Could this be a map of different biomanufacturing centers across the United States, some of which would look like the center that we have here at Boston University? And then what you'd want to do is you'd say, well, some of these centers are experts in certain things. And you would say, well, because we're in the standardized environment, we standardize the data exchange, the material transfer agreements, and then you'd be able to move that design through this. And that might look like places like the DAMP lab here at Boston University, places like the BioFab at the University of Washington, the Colorado State has a similar facility. So you hit these facilities together. And then within facilities themselves, they might do entire workflows. So you can imagine that there's different levels, again, of abstraction. So it's not that you do one thing per location. You may do many things per location, and then you're ending up passing that process to the next. And there's many reasons you might want to do this. I can imagine right now, on Monday at 9 o'clock, our robots aren't doing much. Should they be doing something? Could they be running jobs for other locations? If you think about these as if you look at this the way that we look at cloud computing, Amazon thinks about how much their servers are doing per unit time. And that's kind of how they budget their cloud computing services. They say we have at capacity, we need to add infrastructure, we need to remove infrastructure, we need to schedule that infrastructure. We could think about something similar in a national kind of network. Now, that's not going to happen overnight, but this workshop starts to set, I think, the stage to think about some of these concepts. So again, that's some of the intro, that's some of the vision. The reason that this came up is I have a group. The DAMP lab is not my group. There's some misinformation or misunderstanding about that. The DAMP lab is a core facility on the Charles River campus, just like the Chemical Instrumentation Center, or the center that houses our MRI. It's a center you can take advantage of and use those services. My group is called CITER. So you can see between the two screens, we have some redundancy. My lab makes software, and that software is broken into different aspects: design, build, test. I would make this software and it wasn't very useful to anyone because they're like, not anyone, but the vast majority of people who would sit down in my software didn't also have a lab. So I said, wouldn't it be nice if the outputs of my software went to the cloud, and that cloud would be the DAMP lab? So that cloud would be a facility that if you were using these software tools made by my group or other groups, you would have access to this manufacturing infrastructure. And the idea, of course, would be that this would democratize that process. I suspect there's some young high school age kid that has amazing ideas, and I'd love to be able to get them into the biodesign process, much the way they're able to participate in computing. If it was up to 46-year-olds to make computing, I think we'd be in trouble. Like, you don't want me to think of all the new ideas in computing. You want these folks with lots of great ideas to have access to that infrastructure. So this process starts how to do that ethically, responsibly, and securely. Why is it called IWBDA? Well, let me talk about IWBDA. So you're like, why is this called IWBMA? Because there's a workshop called IWLS in computer science. So my PhD is in electrical engineering. I didn't do biology until I was a postdoc. And in the area that I was in, a very well-known conference on the process of taking high-level descriptions and synthesizing them to components you can make as semiconductors is called IWLS. So in 2009, myself, Mark Riedel, Soha Soon, we started something at an offshoot of a design automation conference called IWBDA, the International Workshop on Biodesign Automation, which was funny because we couldn't get that URL because it also stood for the Iowa Wholesale Beer Distribution Association. So we got that name and we started this in 2009. And then it's kept going since then. It got too unwieldy for that workshop, so we made a nonprofit called the Biodesign Automation Consortia, which runs that today. Some of the members of that are in the room. Tracy Haddock, for example, is a key part of this effort. And we've been running IWBMA, BDA, I'm going to mess it up more than you guys, ever since. And so we've been running this. And in 2023, it'll actually happen this fall as part of something they're making Biodesign Automation Week. And so that is what's happening. And because I wanted to be confusing, I said, let's have the International Workshop on BioManufacturing Automation be a sister event. And so we had this in 2018 here at BU. And the idea was it was going to be every year. And it was kind of corresponding when the DAMP lab got started. Unfortunately, as you know, in 2020, something happened. I would ask you to raise your hand and tell me if you know what happened in 2020. But I suspect all of you know that we stopped having in-person events for a variety of different reasons. And so that kind of got paused. We thought we might do it in 2018, 2020, but this was a great event. Some of you were in the room, were here. It's meant now to reboot this. So the idea is that we're going to continue to have this event. And as what I'm saying, I'm going to show you in a minute, is we're going to start having this event actually in September as part of this larger week. So you'll be able to go to IWBDA, IWBMA, you'll be able to go to something called the Synthetic Biology Open Language Workshop. We're going to involve local Boston area biotech. So stay tuned for more information on that. So again, we got at least one screen. There's some goals you would have. So if you're a researcher, you might think about what automation services are available. So if you're here as a researcher, you should be thinking about what services are available. Thinking about developing ideas, you could partner with a crowd lab, work on interfaces, and think about how automation could be your kind of quote unquote killer app. So you can think of a lot of different reasons, but if you're a researcher, that's one hat you might be wearing. If you're a vendor here, this is an opportunity to see what the DAMP lab is using. You can think about what other researchers would want to use. You can highlight your equipment, your consumables, your robotics. Think about the interfaces that might need to be made to make that network possible. And then if you're a lab itself, I have a couple folks here that actually have their own lab. You can think about how we could exchange information between the DAMP lab and your lab. You could think about joining a network of foundries like the Global Bio Foundries Alliance, and think about education and training programs. So I imagine you can see yourselves in one of these three bins, and I'd encourage you over the next couple of days to think about which goals do you have and help us realize those goals for you. So as I was talking about, I think there's a synergy here that's going to go forward with these other events. So we obviously are having IWBMA. And then what I've mentioned in Boston in September, we're going to have this Bio Design Automation Week, where there'll be IWBDA, there'll be something called the Synthetic Biology Open Language Workshop. That's a standard and data exchange for synthetic biology. And then the Nona Research Foundation, which is a nonprofit for synthetic biology software, will have a hackathon. So it's actually going to be on BU's campus. We're using both this building and we're using the data science building across the street, the interesting block-shaped new building. It's very distinctive. You can't miss it. And we're going to have our workshop there the week of September 10th. And we're going to have more to come there. So you'll be able to interact with many people. It's a whole week-long event. And then this will synergize with the Global Biofoundries Alliance, which is a network of academic labs globally that has a regular workshop. This year, it's in Copenhagen, Denmark. But it'll also, we're going to try to tie also with larger conferences like SLAS and Bio IT World, et cetera, so that we have representation at all these. So this is this larger vision that you all are part of that says, let's take these ideas of cloud manufacturing, cloud computing, apply them to biology, and then to start to spread the gospel of this in all of these different areas. Who's doing this right now? Well, there's a handful of labs. So there's us, the DAMP lab. There's the UIUC's iBioFab. There's one at the University of Washington. There's the Lawrence Berkeley National Lab has an Agile Biofoundry. It's a collection of labs in the National Labs system. NIST has a Living Measurement Foundry, Colorado State, et cetera. So what you should take from this picture is that there are some other people doing this. But this picture doesn't look like my Taco Bell picture. So I have the vision when it looks like that Taco Bell picture, where it's covered in sites that all have capacities to do this, and they're all able to talk on some level through these standardized interchanges and experimental formats. Not all of them will be the same size, and I think that'll be some of the beauty of it, that some small labs do certain things, larger labs do others. But again, from a user standpoint, you don't think about that. You submit your job the same way you submit to the cloud. You don't think about how big the server is. You think about what you need, and then the network scales to give you that. So what are you going to get from this workshop? You're going to get a list of folks at some point, maybe not today, but by the time the dust settles on this, we're going to make sure that everyone knows who came to this workshop. We're recording this talk in all its glory, so you'll have access to that. You'll have access to some of the pilot project talks. You'll have access to Lynn's talk coming up. So select, not all of them, but select talks are recorded. You're going to get summary documents on all the pilot projects. What you're going to see is we're going to go over the pilot projects that were run the first half of 2023 in the DAMP lab. You're going to learn about the brainstorming efforts. You're going to get that distilled. You're going to get the opportunity to have a letter of intent with us to do services, and then you're going to get a survey. And so figure out what deliverable you have, like what deliverable you have for us. Like what should we be giving you? I mean, I joke about this, but what will make you guys come next year? If at the end of this workshop, you're like, well, that was neat, but I wouldn't come next year, somehow we failed. So I want to make sure that all of you give us that feedback. What do you want to get from this workshop? So just really quickly, I want to highlight some things that we're doing. So after this workshop, you're gonna learn about the pilot projects here. We're going to be doing pilot projects in Q3 and Q4. So we need to figure out which of those projects make sense to continue and solicit new projects. We have some sponsor projects. So we have representatives from Merck here, Life Foundries, Capper Bioscience. These are just some examples. So some folks have already said they want to partner with us and we're going to be doing some of those projects. I suspect you'll hear about those at the next IWBMA. We have federal funding opportunities, the biggest of which is we'll be looking at if we can submit a proposal to NSF's BioFoundries recent call. There are efforts with DARPA that we'll be pursuing, perhaps ARPA-H, other places we'd like to look for federal funding. One of the pieces of our funding picture is federal funding. We want to think about key software initiatives, launching our software, and thinking about really how we schedule this. The idea right now is that you would have hundreds of jobs come in, And the question is, how do you schedule those? So we're really thinking about that as a research question. And then we need to have extra staff, increase promotion, infrastructure, messaging, etc. I'm not going to belabor this because you all have a program and that tells you what's coming up. But there are 3 days. I want to make sure folks have a high level idea of what's happening. Today we're going to be in here in the morning, actually until 3 o'clock. So you're going to hear all the talks. You're going to have lunch here. We're going to network. And then at 3 o'clock, we're actually going to go over to the Center for Integrated Life Science Engineering, the Rajan Kilachan Center, which is that way. Well, make sure you can find your way down. Going down is easier than coming up. So we should be in good shape there. And over there, you're going to be able to get tours, networking, cocktails, all of that. So we're going to do that. Day 2 is similar, where we start here, and then we end up going over there in the afternoon. The difference between today and tomorrow at some high level is tomorrow we have a really fun Jeopardy-esque game. We thought, how would we want to do these brainstorming sessions? And you've all been to the one where like get together, meet a stranger, and talk, and everyone kind of gets on their computer and does their email. What I thought we're gonna do something that's gonna be a fun game, but it'll be fun. I'm looking forward to it. We put some thought into it, but we're gonna take the ideas that you all have and capture them in a game format with some prizes and things. We'll hear about the BioNet in the afternoon keynote, and then we're gonna do the same kind of cocktail hour and then we'll close. Day 3. Now, day 3 is for sponsors only. That is when we have a coffee, and this is going to be over all in the other building. That's where we really have an in-depth demonstration of our robotics, our software. You get to talk to the programmers, you get to see how things work, you get to ask them questions. You meet with myself, other DAMP Lab leadership to brainstorm. You get a whole kind of tour of the more detailed tour of the facility, et cetera. That's a more in-depth piece. Now, if you're like, oh man, I really want to go that day 3, I'm not a sponsor, please see us. We can talk about ways that you can become involved and justify that participation. I don't want to turn anyone away that's like, I really need to come to day 3. So do find us, talk to us, and we'll make sure see if it makes sense for you to attend. So what is your homework? I'm a professor at the end of the day, so I have to give you guys some homework. Take a tour of the DAMP Lab. If you leave here without a tour of the DAMP Lab, somehow you have failed. I make the case relatively humbly that it's probably the most automated academic lab that I've seen in terms of its raw liquid handling capability. We have 7 Hamilton Star liquid handling robots. And as Lynn talked about, we did more than 2.5 million, 2.3 plus. We did millions of COVID tests, like a legitimate clinical operation. So take a tour. Talk to 3 vendors. We have a bingo card. It's relatively small, but there's a bingo card in your packet. You fill that out and you can get prizes for visiting vendors. Engage, of course, ask us questions, meet people. I was joking that you'll notice there are no power strips under your tables. So your laptops will run out of power. So you're gonna have to meet people and talk. So, that was all part of our design. Meet 3 new people. Sounds crazy. I know there was this thing before, before COVID when we can meet people and we can talk. That's why we have these events. So please meet people. And then we're going to give you this idea that you please fill out a survey. So again, we're going to get a survey at the end of this. You always get that. Please fill out your survey, yada, yada. Who's really listening? But we are listening because this event is critical to the DAMP Lab's operation. If we have this event next year and there are 10 people, we will have failed. So I want to figure out how to minimally have the same number of people, but grow this event so people are like, are you going to IWBMA this year? Like, of course, I go every year. That's one of the best workshops in this space. So it starts kind of with you guys. So again, I want to thank you guys. I'm going to transition. I want to thank all the sponsors. I already preemptively are thanking our speakers, Dr. Renee Wegerson and Alex Tobias. It's really great that we got folks to speak. Boston University has been tremendously supportive. Gloria Waters, Ken Luchin, Sophia Monkman in Industrial Relations. I missed a ton of people, I guarantee that. It's like any award show. Who am I forgetting? So there's tons of people I really want to thank. The DAMP Lab team, of course. I was joking that I've done nothing for this workshop. I'm joking a little bit, but really the bulk of the effort has been done by a really tremendous